Good morning, lovely nines. Right, buddies. Really good work on the very first online lesson that I've done with you. I was really impressed. Your guys' puzzles looked really good. Lots of you cut and stick it, which was kind of the intention of it, and lots of you did kind of the coloring in or made it match with labels and stuff like that, which was also awesome and really good. So awesome work, Super Nines. You're off to a flying start with our week and a bit worth of quarantine home or quarantine schoolwork. So yeah, cool. Right, buddies. Today is the lesson that I've been so excited about. This is the one that I've been waiting for. In your books, please put the title Bounds of Accuracy. Now, I think this is one of my favorite lessons to teach because I almost guarantee I am going to break your brains today. It is going to be so cool, and you're not even going to believe me when I tell you something today. So, here we go. Title is Bounds of Accuracy. Now, what this does, my lovelies, is essentially you can get numbers that are already rounded. So, if you look at this number here, 45, you see in the brackets it says 2 sig fig next to it, or 2 SF, two significant figures. That's because it was already rounded and it made 45. So this is like an answer, okay? Maybe the original number was like 45.3 and it rounded down. Or maybe the original was 44.8 and it rounded up. So we don't know really what the original number was, but we do know that whatever the original number was, it rounded to 45. Cool. This is going to be the idea of what we call bounds, my lovelies. So it's going to be the question that we're going to ask ourselves is what's the smallest number that this 45 could have been in order that it would still round up to 45? So, for instance, 44.9 would still round up to 45, but is there something smaller than 44.9 that would still round up to 45? Well, if you're thinking, well, 44.7 still rounds up, you're right. Is there anything smaller than 44.7 that still rounds up to 45? And eventually, I'll bet you some of you already have thought of it, the smallest number that still rounds up to make 45 would be something like, well, 44.5. And hopefully that kind of makes sense to you. So here's what we're going to do. That, my lovelies, is actually called a lower bound. So I'm going to put an L here for the lower bound. And again, in case you weren't quite sure what the lower bound of this number was, let's say it one more time. What's the smallest number that is smaller than 45 but still rounds up to 45? Well, my lovelies, the answer was it's not writing. Oh dear. The answer was 44.5. Now there's a trick to it, buddies, and here's what the trick is. See how this was two significant figures? Since that was two significant figures, what it means is the number that was rounded two significant figures had to be more than two significant figures, and it has to be one more than two significant figures, so it has to be three significant figures. So that's why the 45, the smaller one that still rounds to it, is 44.5. It's like one digit more. Cool. What about this one, my lovelies? The lower bound of 12.6 rounded to one decimal place. Well, what number would be smaller than 12.6 but still round up to 12.6? Well, what would it be? Well, would 12.59 still round up? Yeah, it would. 12.58, yep. 12.57, yep. And you eventually get down to 12.55. And you'd be right. Because if you were to round this number, my buddies, if you were to round it, it would look like this. You'd have the round line there, you'd put underline that one, and would it stay as 12.5 and round down, or would it round up to 12.6? Well, it would round up to 12.6, just like we wanted it to. So it's absolutely perfect. Now, I know what you're thinking. You're like, that hasn't broken my brain. That wasn't too bad. That's a bit just kind of normal. That's not outrageous. That's kind of like the regular maths that we learned. But here's the thing. I'm about to make this absolutely crazy. Mind-blowingly crazy. If only I could just make the pen change color, I will make it great. Oh, there it goes. I would make it crazy. Because there's something called an upper bound as well. Now, an upper bound is what's a bigger number than 45, but it still rounds up to 45. It still rounds down to 45. So we're looking for a number that's bigger than 45, but rounds down to 45. Well, 45.1 would certainly work. because that would round back down to 45. 45.2 would work, 45.3 would work, 45.4 would work. But is that as big as you can get? Because 45.5 would round up, wouldn't it? So we're in a bit of a pickle here. So what's the biggest number that would still round up? It couldn't be 45.5 because that would round up. But let's see. 44.4 would certainly round down, so it could be that number. But at the same time, though, is there any number that's bigger than 44.4 that still rounds down to 45? Well, what about 44.41? That's a bigger number, and it still rounds down, doesn't it? Yeah, it does, doesn't it? So that's a bigger number. What about 44.8? Well, that actually still rounds down as well. That's still... Oh, drat, I've got a mistake here. Oh, drat. I'm ruining my explanation. Sorry, it's 45.48 I'm at now. Sorry. I made a mistake there. Here's the mistake. I need a number bigger than 45, but I accidentally put 44. So 45.4 would certainly round down. Here, I'll fix that. Okay. 45.4 would certainly round down. Okay, everyone with me? Sorry about that. I made a mistake there. 45.4 would round down because it's bigger than 45, but it rounds down to 45. Now, 45.5, though, wouldn't work because that'd be 46 that would round to. But what about this? What about 45.41? Well, 45.41 still rounds down to 45, right? What about 44.49? It still rounds down too. Is that the nearest number then? Well, no, because I could actually put another 9. Do you see what I mean, my lovelies? Since the rounding line is here on the decimal place, this first digit, the 4, is what's giving it away. So actually, I could get closer still. If I put 44.499, then another 9, it's still a bigger number, and a bigger number, and a bigger number still, and I could have all these 9s forever. And it would still round down to 45. So basically, my lovelies, the number that we're talking about here is this: 45.49 recurring. Okay, so that seems to be the biggest number, bigger than 45, which still rounds down to 45. Now, you might still be thinking, yeah, that was a bit harder, but that hasn't blown my mind yet. Here's where I'm about to blow your mind. Do you see this, the number 45.49? You guys know that means it's 45.4 and then an infinitely long list of 9s, don't you? Well, here's what I'm about to tell you that's going to change your life. 45.49 recurring is actually exactly the same number as 45.5. Those numbers, while they look different, are actually the same number. And the reason for that, my lovelies, is 0.9 recurring, 0.9 recurring, which is this, isn't nearly 1, because, it gets closer and closer and closer to 1 each time, but it's not nearly 1, it's actually exactly 1. Oh, and I know what you're thinking. You're like, that can't possibly be true because there's always an extra gap for the 9. But the trouble is, you're going to have to keep writing those 9s forever. And if you write an infinite number of 9s forevermore, it means that, well, you're never actually going to get to the spot that needs the infinite number of zeros and the 1 to finish it. Which means these numbers aren't close. They're exactly equal. 0.9 recurring equals 1, my buddies. Oh! You want to blow your mind even more. It's equal to 1 for a different reason too. It looks like it's a different number, right? Because they look different. But here's something else even cool. It's the same way that you see 0.5. That's like the same as a half, right? Two ways of writing the same thing, but they are the same number. I bet you're not happy with it. I hope that you're not happy with it. I hope you're like, he's talking rubbish. That's not true. And that's why I have this slide. Not 0.9 recurring equals 1. That's crazy talk. And you're right. It sounds crazy, but it's not crazy. I can prove to you that it's not crazy. Are you ready to see how this is not crazy? It's real. It's true. And it's going to blow your mind. Well, here we go, buddies. I'm going to show you why it's true. Okay. I can prove it in only a couple of steps. Are you ready? Tell me, what does 1/3 equal to? As a decimal, what would 1/3 equal? Well, I bet some of you know. I bet you're pretty close. I bet Satsuyuka will know that that's 0.3 recurring. Isn't that right? Yeah. Okay, well, let's just prove that that's the case. 1/3 is the same as asking how many 3's go into 1 if you wrote it as a division, if you're going to use your year 7 dividing skills. So your first step, my lovelies, I'm going to put a decimal point there, and I'll put the decimal point there as well. Your first step would be how many 3's go into 1? Well, none, but you still have the 1 left. Put a 0. How many 3's go into 10? Well, 3, because that brings you to 9, with 1 left. Put a 0. How many 3's go into 10? 3, with 1 left. Put a 0. How many 3's go into 10? 3, with 1 left. Put a 0. How many 3's go into 10? 3, with 1 left. Put a 0. Do you see, my buddies, that I could just keep doing that forevermore, and that's the reason that 1/3 equals 0.3 recurring? Do you accept that, my lovelies, that 1/3 equals 0.3 recurring? And I won't use the little dot like you normally do. I'm going to write 0.333 ... to show it's 0.3 recurring. Hopefully, you agree with me that that's true, right? Because I just proved it. Here's what I'm going to ask you to do, guys. Are you ready? Hold on to your hats. I want you to just use regular algebra here like you're allowed to do. And I just want you to times both sides by 3. Okay, so on the left-hand side then, what's 1/3 times 3? So a third looks like this, right? My lovelies, on a piece of pie, it would be like, ooh, yeah, there we go. 1, 2, 3. I didn't draw it super well. Yeah, a third looks like that, right? So a third times 3, my lovelies, is a whole. Do you agree? Good. So a third times 3 is, well, it's 1. What's 0.33333 times 3? Well, the 3 times 3 is 9. And 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 I could do that forever. Well, boom. Proved it. 1 is equal to 0.999 recurring. Same number. Oh, how cool is that? And maybe you still don't believe me, my lovelies. You still might not believe me. Check it out. I'll show you another proof of it as well. This is one of the coolest things that students never believe me when I say. Here's another one as well. If you start off with 0.9 recurring, so 999, boom, 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 and we're going to use some algebra this time, so we'll use x equals that. Okay? So what we're doing is we are letting x equal that. Well, here's what we can do then. Regular old thing. As long as regular algebra works, this is valid. We're going to times both sides by 10. Okie doke. So if you times the left-hand side by 10, what would 10 times x be? Well, if you said 10x, you're absolutely right. What's 0.9999999 times by 10 equal to? Well, it moves the decimal place once. So you'd get 9.999 . Now here's what I'm going to do. All I'm going to do, my buddies, is I'm going to take this side. I'm going to take away x off of this side. So take away x. That's what I'm going to do on the left, okay? Cool. So 10x take away x would be 9x. But on the right-hand side, remember how x was equal to 0.9999? So I'm going to take away x on this side as well. But rather than taking away the x, I'm going to take away the 0.9999999 bit, because that's the same. Well, that means that 9x equals 9, because all the 0.999s would disappear. Divide both sides by 9, x equals 1. Now, in case you forgot, x was also equal to 0.99999 recurring. So if x was equal to both 1 and 0.99999 recurring, it means that 1 equals 0.999 recurring. So my word, my lovelies, 0.9 recurring is not close to 1, it's not nearly 1, like what people kind of think it might be. It's exactly 1. They're the same numbers, which means in this question here, my lovelies, the upper bound of this is 45.5, because 45.5 is the same as 45.49 recurring, which is actually the same answer. Cool! So all I want you to do today, my buddies, is I'm going to get you to do for me, and I'll put it on the Show My Homework so you don't have to remember, I want you to show me 3 proofs, which shows 3 evidences that, why 0.9 recurring is equal to 1. Now, I won't just throw you in to figure this out on your own. I'm going to give you a video which actually has 10 proofs in it, and so you can just copy your favorite 3, and I think this video is awesome. So I'm going to link it, and you're going to watch it as soon as you finish watching this, and you're just going to jot down 3 reasons why 0.9 recurring is equal to 1. The video is here, my buddies, and it's really good. It's by a wonderful, she's an awesome mathematician. Her name's Vi Hart, and I really like this video. You will really enjoy it. I hope you enjoy it anyway, and all your homework is write down 3 reasons why 0.9 recurring is equal to 1. That's it from me, my buddies. I hope I've blown your mind. I hope that you like it. I think it's cool, as you can tell, but I hope you liked it too. Watch the video, and this homework will only take you 10 minutes, so do take your time and actually watch and enjoy the video. Okay? That's it, my lovelies. I shall see you next time. Bye, Super Nines. Bye, buddies.